Assalamu alaikum everyone. Welcome to Mathematics with Shahab Yaqub. Let's look at this question. This is about trigonometry. It's about identity and it's something conceptual over here. Now, this is from May-June 2012. Let me underline it. May-June 2012, variant 1-3. And it's a very nice question. Now, first of all, it's asking, prove the identity. So let's get started with the identity and let me make it thinner. So that is tan square theta minus sine square theta is identical to tan square theta sine square theta. I think I'll start with the left hand side and I'll write tan square as sine square theta over cos square theta minus sine square theta is sine square theta over 1. Now there are two options, either you take LCM first or you take common. I think I'll first take common. So sine square theta is 1 over cosine square theta minus 1. And then when I take LCM, this is sine square theta 1 minus cos square theta over cos square theta. Now we remember this particular identity. There are two identities in P1. Tangent theta is sine theta over cos theta that we have already used over here, and therefore tan square theta is sine square over cos square. And what's the other identity? The other identity is sine square theta plus cosine square theta equals to 1. That means if I make sine square theta the subject, that is 1 minus cos square theta. So 1 minus cos square theta is actually sine square theta. And what's there on the outside? Sine square theta. What's there at the bottom? Cos square theta. Now what am I out to prove? I'm out to prove this equals to tan square multiplying with sine square. So this thing is now tan square theta. And yes, it's multiplying with sine square theta. Of course, there is an alternative answer also, and that happens in some identities. So the left hand side is exactly the same. That is tan square theta minus sine square theta. That is sine power 4 theta over cos square theta. So this is in a parallel universe that you can have an alternative form like this. But coming back to this, I have proven this. I have proven that tan square theta minus sine square theta is a product of these two. Now comes the real part, only for 1 mark, because the difficult parts are asked only for 1 mark. So let me just copy this over here, and let me just copy the question also. And of course, it's related with the first part. What does it say? It says use this result. Which result? This identity. Use this result. Explain why tangent is greater than sine for theta lying between 0 and 90 degrees. Now there are a few things to consider in this thing. The first one is, when we talk about the quadrants, we know that if we are talking about the first quadrant, that is from 0 to 90 degrees. So in this first quadrant, all ratios are positive. We are talking about tangent. Yes, tangent is positive. We are talking about sine. Yes, sine is positive. If positive is squared, therefore tangent square is also positive, sine square is also positive, and the product of two positives. So positive multiplying with positive, naturally that is positive. Got the idea? So now let's focus on the right hand side. On the right hand side, tan square, sine square, since tan is positive, sine is positive, tan square into sine square, that is positive into positive is overall positive. Now what is happening is that what is happening on the left hand side. So on the left hand side, we know that tangent is positive, tan square is positive, sine is positive, sine square is positive. So now it's a difference between the two positives. It's a difference between two positive values. Since we want this difference to be positive, therefore it is necessary that tangent is greater than sine, and we have used the symbol theta. Therefore, tangent theta has to be greater than sine theta because it's bigger minus smaller. It's already positive over here. How can we have a positive on the left hand side? On the left hand side, positive is only possible if tangent is greater than sine. Therefore, tan square will naturally be greater than sine square. Theta, 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 theta over here. That is the logic that we apply. Yes, how do we write it in words? We can write it in words like this. So we will write that tangent is positive and sine is positive in the first quadrant. The squares are also positive. So let me just remove this positive sign. I'm writing over here and therefore the product of tan square and sine square is positive. This is the right hand side of the equation. So right hand side, that is in blue color, that is positive. In order for left equal to the right, left should also be positive. How can it be positive? When tangent is greater than sine, therefore tan square will also be greater than sine square. There is nothing negative over here. Why? Because we are talking about the first quadrant. In the first quadrant, all ratios are positive. So that was a very interesting question. That is of May, June 2012, variant 1.3. So this is all done and dusted. Take care, everyone.